So, after watching my series of videos on Minesweeper, a couple of people had asked me about the differences between structures and classes. So in my Minesweeper program, I had to, at various places, pass around the location of the cell. And the cell was made up of both a column and a row. So I'd created a structure, so I could just pass that round as a single value. And you can see here my structure contains two integers, one represents a row, one represents the column. So the difference is, what's the difference between declaring that as a structure and declaring that as a class? Well, the main differences really just come down to how they're held in memory. So when we say that one is a value type and one is a reference type, so structures are value types, classes are reference types. So a good example is if we just start off looking at something quite simple, such as an integer. So we declare a couple of integers in a function, so x and y. So then in memory we have these two variables now declared. So this is our memory up here. So we have two variables, one called x and one called y. And to start with, that's got value 6. Let's make my font a bit bigger. 6 and 12. So this is in the memory that belongs to this function 1. So then when we call another function, call it function 2, and we can pass in the value, because these are value types, so we pass in the value of one of these variables. So we're going to pass x along. And we'll just rename it here so we can see what's going on. So we'll put that one parameter x. And within this function, we might also declare another value. Do it z this time. Okay. So in memory, we now have two new values. We have our parameter x, which to start with contains 6. And we also have a brand new variable z, which contains our 10. And these values in memory belong to function 2. And we call this type of memory the stack. So each function we call then has a frame on our stack. And the important point here is, because we've passed in a value, we've actually, a value type x is actually a copy of that value. So if we in this function now change that, say 99, so all that we've done is we've changed the copy which belongs to this function. So this function now has 99 for its x, but the original value isn't changed because we didn't pass anything to do with this memory location. We just passed in the value which was in that location. Nope. Never mind, I'll leave that. I was going to tidy up. Okay, so the next thing is, okay, so we looked at simple value types. What happens if we declare a structure? So we use our cell location, which is our structure, and we do it in our function here. We'll say the row is 8 and the column is 7. So what's happened here is, again, in memory for this function 2, we've declared a new variable called location. And location consists of two values, a row and a column. So, and our column is 7, and our row is 8. So this is still part of the memory for function 2. I'll just draw a line to show that. Okay, so another example. So that's with a structure. So with a structure, the values are stored where the structure is defined in memory. We can compare this to a class, however. Another function called function 3, and this time we're still locate location, but we do use our location class. Sniff values. So we do this one down here. So we still have a variable called location, and and this is for function 3. But instead of location holding the row and column, instead it holds a pointer to this object which holds the row and column. So this pointer could be elsewhere in memory. So this is typically on the heap, which should be over here. So that has a row and a column, and this contains the values 88 and 77. So instead of calling the value, this actually holds a pointer to over here. So this gives us a couple of differences. So to begin with, we can immediately see that the difference between structures and classes. The data for a structure is held in memory where it's declared. With a class, however, the data for the class is held on the heap, and we have a pointer to where the heap is. So one difference that means that we can set pointers to null. So if we say location equals null, so what happens in this case is we now break this line. So the data could still be in memory, but we no longer have this pointer from here. Which means that when we then try and access location.row, for example, it goes to here, it reads the location, and it then tries to follow this pointer to find the row. However, we've cleared the pointer, so it can't do any more, less anymore. So this is where we get our null reference exception, because there is no pointer to follow. If on the other hand we try and do that with our structure, I'm trying to set that to null, we find the compiler doesn't let us set it to null. That's because we don't have a pointer, instead we've actually got the data in memory. So structures can never be null, because there's no pointer to set to null. So the next difference is when we return from that function. So when we get to the end of this function, so the end of function 2 for example, and we return back to function 1, all that happens is this area of memory then gets freed up. So this gets removed off the stack. So that all gets deleted. And that's all quite straightforward and all cleaned up. However, when function 3 returns, like that, so the data for function 3 is removed off the stack, so that frame goes, which is fine. But we still have this data in memory on our heap, our object. So this is where our garbage collector comes along, and it will clean this up at a future date. So that's a fairly expensive operation. So we've got 3 differences now between structures and classes. Structures hold the data where they're declared. Classes hold a pointer to where the data is on the heap. Structures can never be null because we've got no pointer to set to null. A class can be null because it does have a pointer to the data in the heap. Cleaning up after a structure, if it's held on the stack, is straightforward because the stack frame is just removed from memory. Cleaning up after a class is a bit harder because we remove the pointer to the heap, and the garbage collector has to tidy up the heap at a later date. The final difference is when we then pass our structure to another function. So we'll call it function 4 in this case. So what's happened here, because it's a value type, we've passed the value of this structure, not a pointer to this structure over here. So in here, so previously location.row would be 8. We now go in here and change it so location.row is 8000. Again, because we've been passed a copy by default of the structure, or the values of the structure, when we change these, we're not updating the ones in the parent, the original copy. So up here, location.row will still be 8, but down here, location.row is 8000. If we did the same thing with the class, so we've passed the reference to this class, not the value to the class. So if we change this column this time, so both this location and this location are both pointing to the same class on the heap. So when I change the value here to 7000, it's also changed it up here because we're both looking at the same object on the heap, which is different to our structure. Just check my notes, see if I've got anything left. Yeah, so how do you tell the difference between the 2 bits of code? So you can't really tell from here whether or not this is going to be a structure or a class you're dealing with, unless you look at sort of the variable itself. So one of the recommendations is you make structures immutable anyway, so you can never change the value in the structure. And then you don't have that problem. If you can't write location.column equals 7,000, then there's no ambiguity. And yeah, the final one is if you have a function that takes in an object. Everything in C# is based on the object type. So function 10. So we can quite happily call function 10 passing in our location, even though location isn't an object. So what happens in this case is it's called boxing, so it puts our structure inside a reference type and then puts that onto the heap. So that's a fairly expensive operation as well. In C# 7.2 there's various other methods to do with structures. So instead of passing in the value of the structure as we've done here, you can use the sort of the ref keyword, which passes in the reference to the structure. You can pass in and in is a read-only reference to the structure as well, which is a slight optimization. So because I've passed it in as being read-only, it doesn't allow me to modify now. Thank you for watching. Hopefully that was useful.